Hello everyone, Carnasa here, and welcome back to a build episode on Kerbal Gets Real, and it's going to be a little bit of a marathon build episode, and I have mentioned this already. Basically, I've unlocked a whole load of new engines, and I really want to redesign a load of launch vehicles, so that is exactly what I'm going to be doing in this episode. So the idea here is I've actually designed a new series of upper stages. So I had the Pegasus upper stage and Pegasus 2, so one RL10 and two RL10 engines, and then I've also designed something called the Minotaur upper stage, which actually uses an LR87 LH2 vacuum engine, and I want to design launch vehicles that hopefully will be able to lift all of those into space. So the idea is I need to design a launch vehicle that is capable of lifting 15 tons, a launch vehicle that is capable of lifting 32 tons, and then a launch vehicle that is capable of lifting 120 tons. So what I'm going to be working on, first one, we'll go in size order. So we're going to be working on the 15-ton one to begin with. And I have kind of done a little bit of experimentation to kind of figure out what I want to, well, what I need to make these vehicles work. Right, so I want this to be roughly 15 tons, don't I? So how are we looking? Let's make this, that's still a bit too much. I just want 15 tons. There we go, 15 tons, there we go, pretty much bang on 15 tons. And yeah, as I was saying, I have already kind of worked out the plans for these. So it's going to be a new series of rockets. They are going to be called the Adventurer series. So let's get that in now. So Adventurer 1. And so there's going to be Adventurer 1 and Adventurer 2. Adventurer 1 is going to be the 15-ton launch vehicle. Adventurer 2 will be the 32-ton launch vehicle. And then for the 120-ton launch vehicle that we are going to be working on, that will be the next iteration of Icarus rockets. It's going to be very similar to an Icarus style. So what the Adventurer series is going to be, they are going to be a sustainer core with boosters. Now, I have unlocked 1975 to 1980 Hydrolox engines. I think that's the technology that I've just researched. You unlock the J2S once that's been done. So I am going to be using a J2S for the sustainer stage. Usually the J2 is really bad in the atmosphere. But the oh, that's not good. We don't want that avionics there. But no, the J2S is actually fairly capable. Its specific impulse is relatively decent in atmosphere. So that's why we are going to be using the J2 as a sustainer engine. And like I said, I've done a little bit of testing of these kind of styles already, and they seem to work fine. Well, hopefully there was a few hiccups in testing, so I'm going to have to try and hopefully iron them out whilst I build these rockets up now. So obviously we've got a balloon tank. We're still limited on the balloon tanks that we have. We have only one type of balloon tank, but still it's probably the best tank that we've got for the job. Very lightweight. And what we're going to do is we're going to go in, we're going to find the J2. I think that's there we go. The engine that is used on the Saturn V for the upper stages, 5 on one stage and 1 on the next. I can't remember what the stages are called off the top of my head. I can't remember. It's S4B, or is it the S1C? No, that's the first stage. I can't remember off the top of my head. But anyway, we're going to get a J2 engine. We are going to configure it to the J2S configuration. It's cheaper as well, which is really nice. Gives us a lot more thrust, which is cool. So almost 1,200 kilonewtons. The ISP is 320 to 436 compared to 100 to 418. So yeah, that atmospheric specific impulse is very poor on that J2 200K. So that's why we can actually use the J2S as a sustainer engine. So let's fill this up with Hydrolox. So we're going to get our Hydrolox in there. And that gives us about 6,700 already, a burn time of 601 seconds. This thing is only rated at 500 seconds, so we are going to have to make this a little bit smaller. Maybe we will go, I think a 3-meter tank might be a little bit too small for a J2, but we'll maybe go something like this. 35.5 meters, 502 seconds of burn time with a vacuum thrust to weight ratio of 0.72. That looks promising, right? So I am going to actually pick this up from the top and flip it round, because I am going to want to place some boosters on the side here, and I don't want those fuel pipes to get in the way. So let's go into coupling, and we are going to grab ourselves a decoupler, the TT38K radial decoupler. We're going to whack a couple of those on the side. That was only one. Let's make sure that we are whacking a couple rather than just one, because we want our symmetry to be all fine and not all weird and wonky and all in the wrong place. So there we go. Now that we've got those decouplers on, let's actually change this up to 90 degrees snap. Not like that, please. Hopefully that's done it correctly. Yes, that looks good. And we're gonna change these to 2 meters in diameter. I think maybe we will go for about 15 meters in length, maybe 16 meters. We'll see what that looks like to begin with. And then we're just gonna move these up. We are going to put a boat tail on there, and actually I'm going to put a boat tail on there as well. I might make a custom build boat tail for that J2, but we'll see. So I do need to make a few slight adjustments to that actual core stage. Right, so mount, we do not want a shroud medium, we want a boat tail, and then we're going to get our good old reliable engines, the LR89 series, and I think we have just unlocked a new config for these as well. So if we place that in there, we can go into engine. So yeah, we've got the LR89 NA7.2, which, what does that do? That gives us a little bit more thrust, so 950 kilonewtons, and the ISP, the specific impulse for both atmosphere and vacuum, is a little bit better, so we might as well use that. I think it costs a little bit more, but not a dramatic amount more. And of course we're going to fill that up with Keralox, because Keralox is what those LR89 engines run on, RP1 rocket fuel. So, oh, I didn't know you could move that. So I'm discovering new stuff all the time. And actually, someone did make a comment on one of my older build episodes about holding down Alt and you can snap to nodes. I found that out on my own, probably maybe about a week or so before that comment. And it was just amazing. It was so helpful to place cargo in cargo bays. It was something that I didn't know about, and I was just kind of gobsmacked. Like, it just made everything so much simpler. Right, okay, so, well, we've got 9,612 meters per second of delta V in here, which is, of course, hopefully that should be enough. However, I am fairly convinced that our thrust to weight ratio is going to be terrible, so we are going to need to sort that out. Right, so let's sort this boat tail out first. We'll whack that J2 engine back on there. We'll make the top a little bit smaller. We'll make the height a little bit bigger, and then that's what I want. We are gonna lower the density of this because we don't need this to be heavy at all. So let's get that height down to about there, and we'll raise the size of the top a little bit. Can we get that? Nope, that's not gonna like that. Okay, so, well, it's nice, and it's got a nice little shroud on it now, I guess. And yeah, so let's have a look. What kind of thrust to weight ratio are we looking on the pad at the moment? I bet it's going to be terrible. 0.93. That's not actually that bad, but I knew this was going to happen, so there is something that I want to whack on this rocket as well. Actually, I guess we can go into Avionics and we can... Oh, have I already configured this? Oh, apparently I have. But we are not going to need this much electric charge in here, so I think what we're going to do is we're going to lower that down to 1,000, and that should do us just nicely. Right, so 1,000 electric charge, that's looking good. How much do we weigh at the moment? So I think we'll probably weigh about 300 tons all in once we're done. So let's whack that up to 300 tons so we can actually control this thing. And the other thing that I want to do is I'm actually going to place some solid rocket boosters on here. I've not been using solid rockets before. I have kind of ignored them in the tech tree, but because there was a point where I couldn't really research anything new because my research and development was limited, I did go in and research a lot of them, and my research has come through. So what I've unlocked, I've not unlocked anything super advanced yet. I'm still quite behind on solid rocket motor tech, but I do have a few that I can come in and grab and potentially use as boosters to actually lift this thing off the pad, because obviously at the moment our our sea level thrust is now actually only 0.52, so we might be in a bit of trouble here. We might have to change that around a little bit. So how much is our sea level thrust? It looks like 1.38, so that is actually quite nice. And then these are going to go, and it will be a thrust to weight ratio of 1.09, yeah, and 1.32 in vacuum. And hopefully, well, these burn for 41 seconds, so hopefully by the time we get to, well, these have burnt out, hopefully we will be in not quite a full vacuum, but a reasonable vacuum, which will be nice. So we've got those solid rocket motors strapped onto the side. We are going to, of course, add some separation motors when these fly off so they don't smash into the launch vehicle. That would be rather bad. So we'll place one up on the top there like that, and then we're going to go down here and we're going to place one just there as well, and hopefully that should translate to all of the other ones. Yes, it has. Perfect. That's exactly what we want to see. And we're going to place a separation motor there, and then we're going to go all the way to the top and we will place a separation motor there. And I think that looks very promising indeed. I don't think there's an awful lot that we actually have to do left to Adventurer 1. So I am going to go in and I am going to make modular launch towers for all of these, but I'm not going to do that in this episode because, as I've said before, I'm still kind of getting used to modular launch towers, and it would take a really long time for me to go in and actually construct those. So this thing is looking rather wacky, but I think hopefully this should work. Let's have a quick look in this. Yeah, it's got a lot of boosters. It's KSP after all. Just strap more boosters on. And I mean, there is a reason why I've got more boosters. So these boosters are providing obviously enough thrust so that we can get off the pad. Well, even with these two LR89 boosters, we don't have enough thrust, but these boosters are more for adding a bit of thrust as well as adding more delta V to get us into orbit. However, these Algol IB solid rocket boosters, their prime purpose is definitely to be providing enough thrust to get us off the launch pad. So that's why we've got those in. Right, so Adventurer 1, the reason why it's called Adventurer 1, I'm not sure if I've been through this already, is because it has one J2 engine on its core stage. A little bit like how the Falcon 9 is called the Falcon 9, because it's got 9 Merlin engines on its engines. Like the Falcon 9. Yeah, like the Falcon 9, because the Falcon 9 has 9 Merlin engines on its core stage. Cool. That was a lot harder to say than I was anticipating. Right, okay, so that's that done, and I think we are probably good to go. We are going to need to sort a few little things out first. So we want our... I've not even put fairings on yet, so that's something that we need to do, so let's get those on. Where are we? Oh, give recolor. Yep, we're going to go for that, and we're going to once again whack the density down. We don't need that to be particularly high. Actually, I think we can maybe make this avionics a little bit smaller as well, so we can reduce that size to just, is it 100 centimeters? 100 millimeters, so 10 centimeters. Yep, that's fine. That will do us just fine. So let's have a look. We want to go into fairing auto shape, and we want to make the cycle end a bit bigger. So what I'm going to do here is I'm actually going to go into my subassembly, and I'm going to see how big the Pegasus X1 is, and hopefully that will give me some kind of idea how big I need this payload fairing to be. So that will go about there. So let's have a look. If I just make this like that, we've not got an awful lot of space left in there, so I think actually this payload fairing is going to have to be a bit bigger. I think maybe... let's make it 16 meters. We'll make it 16 meters, and that should hopefully cover us for any hypergolic stage that we may want here, and any spacecraft that we're going to have here, or maybe we will only have a spacecraft here. We don't know. This should hopefully be one size fits all. And of course, fairings cost quite a lot of money to tool, so we only really want to be tooling this once. So I think, yeah, I think that will do us. How long and big does this make the rocket actually look, though? Because we don't want it to look we don't want it to look silly. I suppose that's not that bad looking. It's very KSP looking, I guess, this rocket. I guess. Right, so that's fine. We will keep that at that size, and let's just get rid of our Pegasus 1 or Pegasus X1 for the moment. And yeah, I think we obviously need to sort out our staging. So 4 separation motors are going to go there, and those 4 are going to go there. Those separation motors are going to go on there when these boosters decouple, and then we are going to want to decouple our fairings once we get to a certain height. And I think that looks like that should be us. And we've got 9,869 meters per second of delta V. But like I said, I've tested these, and I think we need a little bit more than the 9,400 that we usually go for. I have a feeling it's because of the Sustainer J2. It might not be quite as good as some other designs that I have done. So this thing should hopefully be capable of lifting 15 tons to orbit anyway, which is more than enough to lift a Pegasus X1 and about another 5 tons. I think the Pegasus X1 weighs about 10 tons, so another 5 tons on top of that. Hopefully that should be more than enough to be doing some of our smaller missions, maybe missions to, say, Venus or Mars. Okay, so now that that's done, let's get rid of this, go back to simple mode. We are just gonna, like I said, I'm not gonna be bothering with the modular launch towers whilst I actually build this in the build episode. We're just gonna whack a couple of these small little launch clamps on, and we're gonna test this. So I think that should be roughly where we want this to be. Let's get this down. And actually, I'm just gonna check the tooling and see kind of how long this is gonna take to build once we have tooled everything. 16 days. 16 days to launch something that is capable of lifting 150 tons. No, it's definitely not capable of lifting 150 tons. No, that is capable of launching 15 tons. But how much do we weigh? We weigh under 350, which is really nice. So, with that all being done, let's save this up. I think... No, my staging isn't quite correct, because we are going to need to put those there, and then we're going to need to put those Algor IBs on there. And then, now that that's all been done, I am fairly convinced that actually that is everything correct, so we're going to hit save, we're going to go into crash, and we're going to test this thing. Right, so we are on the launch pad with the first test of Adventurer 1. Obviously, I haven't painted this rocket yet. That will come once we've actually tested and made sure that this thing can work. So let's engage autopilot. See, we've only got 677.8 meters per second remaining, which is way under the 800 that I would usually like, although I have a feeling this should work. We will see, though, once we launch this thing. So we're going to start the launch now. And... well, that's embarrassing. Oh dear. So, yeah, I messed up a bit. We do not have enough avionics on this, so I'm going to go quickly back and sort that. Right, so we're back on the launch pad, and hopefully this time I have sorted out the avionics. That was a little bit embarrassing. Whoops. Okay, so let's try this. And hopefully this should work this time. So we've got all of those liquid engines, hydrolox and kerolox firing up, and our solid rockets go when we detach those clamps, because they don't take any time to thrust up at all. So that's why they are set to stage once the clamps get released. Sweet, so it looks like we are on our way up, and that is still going down rather rapidly. I am gonna 4 times busy time warp this just so that we can get through this rather quickly. Okay, so that is still going down at a rather alarming rate. Hopefully that starts, well, it's going up again. There go our solid rockets, and I think they collided into each other. I wasn't quite sure, I didn't quite catch that, but it's gradually slowing down. This is going to be a really tight margin if we actually get into orbit with this thing. I think we might, but I think this will be just about perfect to get 15 tons to low Earth orbit, which, to be honest, is exactly where we want it to be, because otherwise that's just a waste of delta V. So this could be, although it is going down once again rather rapidly, but our J2 engine has Well, hopefully it should finish the job. Okay, so come on, we can do it, we can do it. I believe in you. You are the rocket that can. Although that is still going down. Oh well. Well, I guess we'll just have to wait and see what happens in this. Well, it's going to be a rather long ascent. We've still got 5,000 odd meters per second of delta V in this J2 stage that, well, and 270 seconds of burn time. I think we are going to be okay, though. I am fairly sure we're going to be okay. But yeah, I wanted to design a whole load of new launch vehicles just because it'd been a while since I designed any, and obviously I am running with a fair bit better technology now. So I thought I'd dedicate a build episode to building these. We are about halfway through 1965 at the moment, I think the 27th of September. So yeah, and I aim to get this up and then hopefully 1965 Part 2 the day after. Just because I want to live stream the start of 1966 Part 1 again. I really enjoyed live streaming Part 1 of 1965. Well, I say Part 1. It was halfway through Part 1. But yeah, no, it is definitely something that I do want to be doing more in the future. So, there we go. We have made it into orbit. We are at a 160 kilometer circular orbit, roughly. And we had 5 meters per second of delta V left in that launch vehicle. So that is pretty much perfect. I think we aren't going to make any edits to that. That is absolutely wonderful. It works. It gets 15 tons up to low Earth orbit. It gets it up with nothing to spare. So yeah, that will be us for Adventurer 1. I'm going to head back to the vehicle assembly building now and just finish off a few little bits. So Adventurer 1 looks like it all works. So what I'm going to do now is I'm going to go away for a bit whilst I colour this thing in and set it to super fast speed so you don't have to sit through me deciding a colour scheme for this rocket. And there we go, that is the end of Adventurer 1, and I've decided to go for a completely different colour scheme than I would usually go for. It's very silver, it's very shiny. I kind of like the look of it. It's very similar to other rockets that I've done with the black and orange, but yeah, no, we've just made it a little bit shinier, and I'm really enjoying the look of this. So, now that that's done, straight on to the next one. And of course, the next one... Oh, no, actually, no. First of all, no, we've got the all-important thing to do where we are going to make this a sub-assembly. So, let's grab this by the payload adapter. That's what we want. Sub-assembly drop zone. I'm getting quite a rather large amount of sub-assemblies in my sub-assemblies section now, so that's always nice. What is this? This is Adventurer 1. Adventurer 1, and the description is going to be 15-ton low Earth orbit launch vehicle, 1966. I've decided that I'm going to put the dates on now, so I know roughly when these have been designed. Well, not roughly, I know exactly this. Well, no, it wasn't designed in 1966, it was designed in 1965, but probably this will see its first use in 66. Probably, I don't know. Depends on the missions that we launch. Okay, so Adventurer 1 is done. We are going to, well, save and continue. And we are going to move on to Adventurer 2. And Adventurer 2 is going to be, well, a 32-ton low Earth orbit launch vehicle. And the reason why this is Adventurer 2 and that was Adventurer 1, I already mentioned it, but you know, it's because it's going to have a sustainer stage which has 2 J2S engines on board. Okay, so we don't need that. We need our integral tank, which we are of course going to fill up with lead. The reason being so we can actually figure out how much 32 tons is. So I'm just going to make that like that, and I don't actually think I told Adventurer 1. Oh well, we'll do that when we actually launch it for the first time. So let's get our engineers report up so we can see it's 7 tons at the moment. We want this to be about 32 tons. That is way too much, so let's make this maybe 1.5 by 1.9 2901220, bit more, 19230. Yep, that sounds like that sitcom, American sitcom 90210, I think. Something my wife watches anyway. I've never seen it. Right. Okay, so we know that we have 32 tons on here, so we can start building a launch vehicle around this. Okay, so once again, this is going to look incredibly similar to the last rocket that we just designed. But oh well, I'm going to try and rush through this one quite quickly. So size, I think we want that 5. We're going to go in. We're going to get some avionics in because we're going to need to be able to control this. We're going to place that there just like that. We're going to obviously make that diameter 5 meters as well, so it matches the core size of the rocket. We're going to take that down to 100 millimeters, change it up to service module 4, make the utilization as best as we can. We're going to change this to maybe about 1,000 electric charge so we don't run out of electric charge whilst we are launching this thing. We are going to leave the antenna on for now, but I will have to remember to turn that off. It's just so that when I test this, that I can actually control it. Okay, so I think that's everything done with our this at the moment. Well, we do need to change our control mass, but that will come once we figured out how big this thing is actually going to be. Right, so we want a balloon tank. Once again, balloon tanks are the best for this. Well, they're just so lightweight. They are absolutely amazing. I am going to flip them around again, though, exactly like I did for Adventurer 1. We're going to make this rather big, and then we're going to whack, once again, a boat tail on the bottom. We'll get this. We'll make a custom one, and that needs to be 5, probably by about 4, 3, 4. The height will need to go up a little bit as well. We're going to grab our J2 engines, and once again, we are going to turn them to the J2S. Where are the J2s? There it is. That's what we want to see. And I think we'll set our snap to 90 degrees, and we don't want to have 4 of these. No, we just want 2. 2 will do us fine, and we're going to move those a little bit closer together and inset them into the tank just a little bit so that all of these pipes and inner workings are fitting. They're connected, they're not floating. Right, so we can go in now and change it to the J2S. That's great that it costs less money. It's better and it costs less money, so that's fantastic. We'll be using that pretty much all the time. Change that utilization up to 100, and we will fill it once again with hydrolox. And now what does that say we're getting? 6,188 meters per second. That's not bad. That's not bad, but I think we can do a bit better. So let's make this, yeah, 470, rated burn time of 500 seconds. I think that should do us nicely. Now, the next step is to get those first boosters on, and what we're going to be doing is we are going to be doing exactly the same, except this time we're not going to be using the LR89s. No, we are going to go one step bigger. We are going to be using the E1 engines, because I have also just unlocked an upgrade for those as well with 1976 to 1980 orbital rocketry, I believe. So I think what we're going to want is, I think, maybe a diameter of 3 meters, and then we will find those E1 engines and we will whack those on there. Maybe we can actually give this a boat tail. Let's have a look and see what that looks like. So SLS, no. We want boat tail. Keralox boat tail. Yep, that looks good. We're going to fill this with Keralox once again. E1s run on RP1, so that's why we are going to be filling that up with Keralox. Sweet. So now we're just going to make these bigger. And actually, wait, no, we need to upgrade them. These do cost a bit more, but if you look, they provide about 500 more kilonewtons of thrust, which is great. And their specific impulse is also much better in both vacuum and atmosphere. So it's a bit of a no-brainer, really. Right, so we're going to whack these up into there, just like we did with our LR89s on the Adventurer 1. We are going to make the nose 11 again, and this is basically going to be the bigger brother to the Adventurer 1. It will look pretty much identical, so let's see kind of what that gives us. That gives us 186 seconds of burn time. I don't think these can last that long. Oh no, they can last 240 seconds, so that is actually enough. And once again, our sea level thrust to weight ratio is looking like it's seen better days. So we are going to need to add some solid rocket motors onto this as well. It'll be nice when I unlock a little bit more advanced solid rocket motors, because at the moment what I'm using, well, they're pretty basic stuff. It's pretty basic stuff. It is the earliest. I'm not even sure if I've gone past 1960 solid rocket motors yet. So yeah, it'll be nice when I unlock maybe like the RSRM, even the space shuttle solid rocket motor, because that thing looks very cool and it is very powerful. So that'll be nice when we get stuff like that. Okay, but anyway, I digress. Where are we? We want the Algol IB once again, and we are just going to stick 4 of those on again. It's funny how much bigger this rocket is, but I'm fairly convinced that 4 of these should do us the trick to actually get our thrust to weight ratio up to a point where it should be. So it's 1.17, which isn't particularly great. It's not particularly great, but I guess it should be fine. It should be fine. We've got 10,034 meters per second of delta V. So maybe what we do is we lower this size down to 18, and then we get a thrust to weight ratio of 1.23 off the pad, and still 9,911 meters per second of delta V is what I was going for there. Okay, so that's that done. Now we want to add on our boat tail, so let's get that on quickly. Like I said, I'm going to try and rush through this because it is basically the same as the last one that I just designed, except just a little bit bigger. So we want the height to come down, not quite that far though. And I think that's probably about where we want it. We want the top to come out just a little bit more, maybe the height down a little bit more. And that looks like it's going to do us the job. And no, I'm not going to recolor it at the moment because once again, I do need to test this. These are all really funny. Like, this should definitely work with 9,878 meters per second of delta V, but I don't know. There's a good chance that it won't. So here we go. Let's get our separation motors on. Do this rather quick and sharpish. Where are we looking? And I'm right in the middle of the rocket at the moment. There we go. That's where we're going to want that one. And then we're going to want one down at the bottom as well. And then we're going to want them on all of these solid rocket motors so that when they separate, hopefully they don't come smashing back into our spacecraft. Cool. Smashing, as Nigel Thornberry would say. Anyway, we are going to go for... Those need to go there, and those need to go there because those are for the solid rocket motors. And then they need to go there, and then they need to go there because they are for our actual main boosters, our E1 boosters, the big boosters. Okay, so what's our thrust to weight ratio? Our thrust to weight ratio is looking fairly good all the way through, so I'm quite happy with this. As long as that 9,877 meters per second of delta V is enough to get us to orbit, this should be fine. How much do we weigh? 632 tons, so obviously we are going to need to make this up to, I think maybe we'll go for 650. And the last piece of the puzzle that we are going to need to do for now anyway, before actually, wait, is that only got one fairing node? No, we need 2. Yeah, there we go. That's a bit better. Right, so yeah, no, before we go and test this, we need to put our payload fairing on, and I believe in order to fit our Pegasus X2, this is going to need to be about 18 meters in length, I think. So actually, once again, we're going to go into our sub-assemblies and we're going to find Pegasus X2 and we're just going to try and compare it. So that's going to be about there. Let's just make this size 1. Bearing in mind everything else will be a little bit bigger. I suppose, yeah, 18 I think will do us absolutely fine. So I think, yeah, that's good for us. So we're gonna sort that out, change that density down. We need to put some separation motors up on the top. I'm not sure if I didn't change the density of that. That's wonderful. Now that we've gone in and done that, now we just need to add some separation motors at the top and a few launch clamps before we go and test this thing. And then that will be 2 done in a relatively quick amount of time. I feel like I've been trying to do this one quite quickly, so There we go. Where have those 6 gone? They are there. They need to go there. And we are going to grab this, whack that back on there, and then we will separate those payload fairings when we get to there. And I think that is that done for the most part. Let's just get our launch clamps on so we can hold this steady. That's not where we want that to be at all. Let's change that down to 2, and we'll just get 2 on there. So, like I said, I am going to go in and I'm going to change these and make the modular launch pads, but for the purposes of testing, I'm just going to do this. So, we want those to go there, and we want those solid rocket motors to once again fire when the launch clamps detach. Those all to fire up at the same time. Solid rocket motors to go first, and then the E1 boosters to go, then our payload fairing goes, and I think that will do us just fine. So let's once again go and test this thing and make sure it all works. We are live on the launch pad with the first test of Adventurer 2, which is, well, kind of comically in the middle of the air at the moment. That will change. That will change once I actually build up a proper launch pad for this. Okay, so once again, we are going to engage autopilot. We're going to try and hit 160 by 160. We want to go for our current orbital inclination. And we're going to have 801 meters per second left in this stage. So I think we are absolutely fine for this launch vehicle as long as it can get off the pad, because obviously that thrust-to-weight ratio very small at the moment, but these solid rocket motors should really help with that. So let's fire this up and see what happens. And luckily this time I actually configured the avionics correctly, so we didn't go crashing back down onto the launch pad, because that was rather embarrassing when that happened before. But oh well, we seem to be going up towards space, and once again we are going to physical time warp through this. This is just for the purposes of testing. Once these rockets are actually built and they will be launched in the regular Kerbal Gets Real series, we are going to be seeing these in, well, a lot better. So that's why I'm just going to skip through these as quickly as possible. There we go. We just had our solid rocket motors detach. We are still coming down quite rapidly, but I am fairly certain we will be fine. I'm not sure if I want to limit my acceleration to 45 meters per second though, so I am going to tone that down. Why are we going back up? Is it just because that I've turned that off? I don't know. There we go. The E1 boosters have now separated. And we hopefully, well, we will still, yeah, we're going to be fine for this. We are going to be absolutely fine. It's going to get to orbit. It will get to orbit. I would be very surprised if this doesn't get to orbit. But anyway, whilst this is on its way up to space once again, I guess what I want to talk about is probably 1965 Part 2. As you can see, we are in September of 1965. It has taken a long time to get here. So 1965 Part 2 has been incredibly busy. Up to this point, I think I have done 5 launches already. I've got another 3 planned for that Venus window that is coming up in 45 days. And then I also want to start thinking about a lunar space station, which I think will also happen in 1965 Part 2. So it's gonna either be, well, a really long episode, or I'm gonna have to cut a lot out, or I'm gonna have to speed through a lot, or I'm gonna have to split it. And I don't think I want to split it yet. Ideally, I want to be getting to the 70s before I start splitting it into quarterly installments, just because I did the 50s. 50s was a year each. 60s has been a year over 2 episodes. And then maybe when we get to the 70s, we will start doing 4 episodes a year, but I'll see. But anyway, yeah, it was completely successful. We had 80 meters per second of delta V left on this, and if I check, did 4.5 Gs. So I guess if we limit the acceleration, which we will be able to do with these J2Ss, this is potentially human rated. So this might actually work out being a good vehicle to send crew up to low Earth orbit. Can get 32 tons up. So I think that's probably a decent tonnage to get a crew and some supplies and all of that to low Earth orbit. But yeah, cool. So Adventurer 2 works. So let's go back to the vehicle assembly building and save this up. And yeah, that will, well, we'll then color it in and do all of that. So we're back in the vehicle assembly building with Adventurer 2, and I'm just going to fast forward this next bit once again whilst I paint this rocket. And there we go, Adventurer 2 has all been painted and it is all finished. So once again, let's go and put this in as a sub-assembly, and then we will work on Icarus Super, which is going to be our next super heavy launch vehicle capable of lifting 120 tons. What is going on? Okay, so apparently I just copied the entire thing. I don't know how that happened. Right, so we want to save this as Adventurer 2, which is going to be a 32-ton low Earth orbit launch vehicle. Yeah, that's it. And once again, yeah, I'm going to put 1966. Again, we'll save that up, and that looks like we are all done with Adventurer 2. So save. So this isn't a super heavy launch vehicle. I think to classify as a super heavy launch vehicle, it has to be able to lift over 50 tons to low Earth orbit. So this doesn't quite make the cut, but it's getting close. So now that we're done with that, yeah, let's start a new one. I did say this is going to be a bit of a marathon build episode, so we are going to go and work on our final build, which is going to be Icarus Super. And it is going to follow the basic structure of an Icarus rocket, and it's just going to be able to lift a lot more than a standard Icarus rocket. So I think this is also going to be our first ever launch vehicle that is 8 meters in diameter. So it's going to be wide, it's going to be very big, it's going to be chunky and huge, and yeah, it's going to be massive. Right, so now that we've done that, once again, no, I don't want to open up the recoloring GUI. I want to go in and tank GUI. That's what I want. We want to fill this full of lead, and we're already at 56 tons. We can make that more to where we want to be. So we want it to be about 120.099 tons. I think that's going to do us absolutely fine. And of course, we're going to move this quite a way up because this thing is going to be really rather large. So now that that's done, let's get our payload adapter. Where are we looking? This is, oh, hello, it's disappeared. It's gone away. It doesn't want to be placed, and we have placed that incorrectly, but that's an easy fix. There we go. Once again, we're going to get our avionics in. So avionics procedural, wait, what? It vanished. No, it's there. It's fine. We have recovered it. So let's go and make this 8 as well. And I think we can make that down to just 100 millimeters again. We're going to set it up to service module 4, and we are going to, I think we're going to go for 2000 for this because this is going to be quite considerably heavier. So we're going to be using a lot more electric charge in that avionics than the previous 2 rockets that we have built. So there we go. We're going to get our balloon tank in, set it to 8 meters in diameter, and that is fine and dandy, and maybe 25 meters. I'm not entirely sure. We will see when we get to it. Okay, so I'm going to use a new engine for this. We are going to be using the HG3, an untried engine that we have not used yet, but a very good Hydrolox engine. So, and actually, you know what I'm going to do? I'm going to make a boat tail. I'm going to make a boat tail out of this. So we will set that to 8 meters, and the top will be 8 meters, and then we are going to place these 4 HG3 engines on like that. 45-degree snap, that should be fine. We do not want to change it to the surface level variant. No, this is going to be launched in, well, this will be lit in the air, so we definitely want this to be just the regular variant of the HG3 that we have. Okay, so we're going to fill it up with Hydrolox. And what is that telling us? We can probably make this stage a bit bigger is what it's telling us. Let's make this 30 meters in length. Our thrust to weight ratio is 0.88. So let's make it maybe 28, 0.93, 6,000 meters per second already. So I think that will be fine for now. We're gonna probably have to do a little bit of experimentation with this, but we'll see how that does us. We're gonna get these S2 ullage motors used on the Saturn rocket to basically ullage this stage and to deorbit us. Once we have made orbit, there we go, that is exactly what we want. Okay, so I now want an interstage ring. We're going to make the height of this a little bit bigger so we can actually see where we're placing this. So that goes there like that. Then we're going to make this 8 meters by 8 meters because, of course, this is an 8-meter core. Now, what I'm going to do is I'm going to get some of these on, and we obviously don't need them this high anymore. So I think we're going to go around there. Yeah, I think that will do the trick for now, and we're actually only going to have one fairing node. And then we're gonna put these on here, and that's that stage all done. Although we can lower the height of this maybe to about 1 meter. There we go, and that's our interstage done, and a new style of interstage with the boat tail on it. So it will look a little bit more like the Saturn V, I guess, with having that boat tail on that section. I'm not sure if it's really necessary, but I think it looks quite cool, and it's a new kind of design feature for this series of rockets. And of course I have placed that balloon tank in a really awkward place. It's gonna be really hard to get this out. So actually, no, that wasn't all that difficult, but can we place it where it should be? There we go. That's where we want this to be. Okay, so we're gonna make this. This is obviously Keralox. This is going to be fueled by, I think, maybe 3 F1A engines. We'll see how they perform. So, like I said, this thing is going to be massive. This is going to be by far the biggest launch vehicle we have designed. Although, actually, no, it's going to be a little bit smaller than the Heracles 64, the Heracles Super 64, which was also capable of lifting 120 tons to low Earth orbit, but I wanted a dedicated 120 tons lifter. So let's make that up to 100% utilization, and we are going to not put a boat tail on the bottom of this. Actually, what I'm going to do is I'm going to make a mount. What mount do I want? I'm gonna go for Pyrrhos, I think. I think that's what we're gonna be going for, so let's try this, and let's go grab the F1. Now, where am I looking? F1. So I have unlocked the F1A, which is what we're gonna be doing, what we're gonna be using this. Well, the F1A, this one, is throttleable, which is really nice. Really nice to have a throttleable F1. However, I don't want to use it, because if we go in here and we change this to the F1A, we can actually see the F1A is cheaper. So that's going to be about 1,800 funds now. This one is 4,200, which is quite considerably more. So I'm going to try and, yeah, do this as cheaply as possible. But there we go. We've got the... no. We've got the F1 in there so far, but we need to kind of make it go down a little bit, because currently it is way too high up. Right, so there we go. We've offset that down slightly. Maybe we can put that up a little bit. And then what we're going to do is we're going to grab both of these. Well, this. And then we're going to place another 2 just on the side. And where can that go? Maybe around there. I think that is looking promising. Now we need to fill this up with Keralox. Make sure these are all firing at the same time. So we are getting a very, very, very poor thrust to weight ratio. That's going to have to change. Well, we can see we've got 9,914 meters per second of delta V. So we've got a fair decent amount of delta V, so we can do a little bit of tweaking with this to make it a little bit better. I just want to find some of those ullage motors so that when we detach this stage, well, it's a nice detach. So where have they gone? Oh, I've accidentally typed in 1. That might be why I can't find them. Okay, so, yep, S2 ullage motor. We will place another 4 of these on this stage. There we go. So that should send our rocket crashing back down to Earth. Well, it'll go crashing back down to Earth anyway, because this is by no means going to get anywhere near orbit, but you know. Right, so that interstage ring, we're going to want to place that there, and then we're going to want those HG3 engines to fire. That will go at the same time. Where is... Yeah, we want those to go there. Okay, so 1.02 meters, not meters per second, 1.02 thrust to weight ratio. That's not very good. That's not very good. And we are going to need to come in and actually sort out our avionics. So we need 2,500 roughly. So let's get this up to 2,450. That should be enough. So our delta V is now 9,874 meters per second. So we can actually get rid of some of this stage, which I think we are definitely going to need to do. So 9,680, and we're on thrust to weight ratio of 1.09. 1.14. How long can these burn for? 315 seconds. So yeah, we may be able to get away. Oh, that's going to be cutting it rather tight. I think actually I'm gonna want to go for a thrust to weight ratio of 1.14, and then we have 9,542 meters per second of delta V. So that should do us. I didn't check and see how long those HG3s burnt for. How long does that stage burn for? 364 seconds. I think they can burn for 600. I'm going to quickly go in and check that. Let's have a look. Kerbal engineer, get out of the way. Was that 600? I think that was 600. They've got a really high ignition failure rate. Oh, that's not very good. So yeah, 600 seconds, and I think what we're going to do is enable an extra pre-flight. So that's still a really high ignition failure rate. I guess it's a completely new engine that we've never used before. So yeah, that's a little bit worrying. Hopefully nothing too bad comes of that, but we will have to see, because this is going to be a really expensive rocket. It's capable of lifting 120 tons. So we will get a lot of testing in with these HD3s though, I suppose. So hopefully that's not all too bad in the end, and we are going to need to move these a little bit further down because I changed the dimensions of this. It made everything a little bit funky. Right, so that's all done. We can actually lower our avionics now because we have managed to get rid of some of that. So let's change it up to 2,200, I guess, will be where we want to go for. I do need to work out the payload ratio for all of these as well, and that will be something that I will probably put in the description of this video once I've worked it out, because that would take me a little bit. Oh, I didn't want to do that. Come on, back to zero. Back to zero. There we go. Yeah, I'll put that in the description of this video, the payload ratio of all of these launch vehicles that I've designed. I think they should all be relatively good. So this is 2,150 tons, and we can launch 120 tons to low Earth orbit. So that, off the top of my head, that's about 5%, I think, or thereabouts. No, that's the that is the wrong thing. So let's make this, I think we'll make this 25. 25. Now let's get the Minotaur out and see actually how big this is. So where are we? Minotaur 1. This is quite a big stage. So that's going to be about there. I might make this actually slightly bigger. I think maybe. Yeah, I think we'll make this maybe 28. That's another 3 meters. How big does this look now? It is basically an Icarus again, but with a little bit of a different mount. That payload fairing, that's not looking too bad, I guess. And to be honest, when it comes to it, when I start launching actual missions with this rocket, what I might do is I might discover that might be a little bit too small. Actually, I'm going to change it to 30. I'm going to change it to 30 if I can select it. But we are going to lower the density down, and we're only on 9,485 meters per second now. That's not that much over 9,400. Well, we'll see when we check this thing out. So yeah, let's raise that up to 30 meters. Now that that's done, those are going to fire. Those are going to all go off at once, and then we are going to want to get rid of our payload adapters, payload fairings around there. So I think that is us mostly done. Once again, we are just going to be whacking on some generic launch clamps just to test this. Once again, we are going to be testing this because testing is key. Testing is very important. Always test your rockets. Always test every aspect of your rockets just so you know exactly what you're doing. Well, not exactly what you're doing. You know, well, you've tested every stage, so nothing can go wrong. Nothing can go wrong. And I have a feeling, I reckon the first time I launch one of these, there will be a failure because that is a very high failure chance. But we'll see when we get to it. Right, so now that that's all done, do we have enough electric charge in here? How long's that electric charge going to last? Let's get rid of those launch clamps just to give me a better indication. 21 minutes. So that is more than enough. I think it will probably take around, what, like 8 minutes to get to orbit, I guess? So there we go. We'll place those launch clamps on there. We can get rid of the Kerbalism info screen. We'll move that up there. 1.14 off the pad. It's not too bad. It's not too bad. And then we've got 0.98 on our HG3 stage. So I think that will probably do us now. So this is going to be the Icarus Super. And we'll save that. And then we will come in and once again, we're going to test this thing because, yeah, testing is key. So I'll see you on the launch pad. So once again on the launch pad for hopefully the last test of this build episode. And look how massive this thing is. So let's set ourselves up and make sure that everything is all in working order. I think that configuration of ascent guidance should be okay. So 957, that is looking very promising indeed. So let's fire this thing up. There goes those F1 engines, all three of those. And we have liftoff with the most massive rocket that I've designed. Although, no, it's not the most massive because, like I said, the Heracles 64, well, the Heracles Super 64 was definitely larger than this thing. I think that thing weighed almost 3,000 tons. This is just over 2,000 tons, so this is quite considerably lighter. We are still going to have to launch this on the largest launch pad that we have available to us, the unlimited one, because anything over 1,500 tons has to be launched on that. But yeah, I think hopefully this should save us a bit of money with super heavy launches. And we are definitely going to be considering a fair few super heavy launches in the foreseeable future. We are going to want to be sending things like space stations to the moon, lunar bases. Maybe we're going to be constructing some bigger things in low Earth orbit that we might send off towards Mars or Venus. Well, once we start sending humans that way, we are definitely going to need a fleet of super heavy launch vehicles. And actually, we will probably need to design maybe a 200, maybe even a 250-ton low Earth orbit launch vehicle. But we don't need that yet. That's something that we can cross that bridge when we come to it in the future. But enough of this now. Let's actually just speed through the last of this launch. Okay, so everything is still looking rather promising. So I think we have designed our 120-ton low Earth orbit launch vehicle that will be, well, yeah, we'll probably use this for a while. And the Icarus series of rockets does seem to be the kind of most used series of rockets that I have been using, I guess. It's just the design seems to work well with a Keralox lower stage and then a Hydrolox upper stage. Usually, I think the Icarus X had 2 J2s on its upper stage and 4 E1s. That didn't look particularly promising. And the Icarus 1, what did the Icarus 1? Well, actually, no, it changed to the Icarus 2 because when I updated my game, the Icarus 1 got deleted because of the LR87 LH2 engine that was on it. Yeah, so the Icarus 1 had 2 E1 engines and a LR87 LH2 on its upper stage. And yeah, the design seems to just work. And once again, it looks like this design is going to work because we're staying at a very nice 215 meters per second of delta V left, which is obviously, well, yeah, that's positive. That's positive, so we won't run out of fuel. So I'm fairly sure the Icarus Super is going to be our next super heavy launch vehicle. It's going to be our next super heavy launch vehicle, and then we're going to make an awful lot of use out of the Adventurer series of rockets as well. So I said at the start of the episode, basically, I am trying to tailor fit these all around those 3 upper stages. Well, the 3 transfer stages, I guess, that I have built. And by the looks of things, we should be able to lift all of those up into low Earth orbit and then some. So yeah, because we're going to need just more than the transfer stage in some cases. So I've given a bit of leeway when I have designed these rockets. So I think the Minotaur only weighs 10 tons, that upper stage. It's around 10 tons, so that means we've got an additional... The Minotaur weighs way more than 10 tons. The Minotaur upper stage weighs 100 tons. So what we've got is after that upper stage, with this launch vehicle, we'll have an additional 20 tons after that transfer stage. And then with the Adventurer 2, I think the Pegasus X2 weighs around... I think that weighs around 20 tons. So we've got 12 tons extra, and then Pegasus X1 weighs 10 tons, so we've got 5 tons extra. So yeah, so I have kind of designed these all with that in mind. But anyway, yeah, no, we got up into space completely fine, so we can just send ourselves back and catch the boat tail on. But yeah, that all works. So once again, we're going to go back to the vehicle assembly building, quickly paint this thing up, and then that will be the episode. So yeah, we are back in the vehicle assembly building, and once again we're going to go for a little bit of a speedy zoom time whilst I paint this thing up, and I think I'm going to try and paint it as best as I can remember what Icarus looked like before. So there we have it, the Icarus Super, and well, we need to obviously put this in as a sub-assembly, but before I'm going to do that, it's time to see how much this thing is going to cost at all. Obviously, I've gone up to a new diameter of tank, so I have a feeling this could cost me quite a pretty penny. So... yeah, I'm seeing tooling costs of 300,000 coming up, and a couple of them. So yeah, this might be expensive, but how much? It's only going to cost... it's going to take 60 days to build this rocket once we're done, which is really good. So let's bite the bullet. 548,000 funds, but I do have over, well, nearly 3 million funds. So yeah, we're just going to do that. We're going to do that. It works. We know it works. And ouch, that was a big hit to my budget. But now that that's done, we can go in and we can place this within our sub-assemblies, which is really getting rather full now. I do love sub-assemblies. I do rely on them all the time. It just makes building so much quicker once you've got, well, launch vehicles. And something that I've started with this series as well, which I've never really done before, is upper stages. So the Minotaur, the Pegasus series, I've never really done that before, but that has helped considerably as well, especially now that I'm designing launch vehicles around them. But anyway, the Icarus Super, and Super has to be in all caps. It's shouty, it's loud, it's aggressive. So the Icarus Super, I think we'll put 66 after that. Anything with Super has to have the year after the name, I guess, after Super. So there, that's going to be a naming convention that I've just made up on the spot just there. Okay, so this is a 120-ton low Earth orbit launch vehicle, 1966, and I'm fairly sure that this can be human rated as well. So we might even see astronauts being launched on future lunar missions on this thing. But there we go. We have now saved that up, and that will be it. That will be us done. We have designed 3 new launch vehicles in this episode. I am now going to go in and probably spend far too long designing modular launch towers for all 3 of those. And yeah, that's that. But if you have enjoyed this episode, why not give it a like? If you have really enjoyed this episode and would like to continue with the content on my channel, please do consider subscribing. I have been Carnasa, and I will see you later.